For this lesson, we are going to go over some of the problems on the DMA for unit number 5, which is about rational and irrational numbers. I'm hoping that this unit DMA will be pretty easy for most people because of the work and the practice that we've been doing on DMR-F for the last couple of weeks. Now, I am going to look at the actual questions on the DMA for unit number 5, and I'm going to discuss each question, but I'm not going to actually tell you what the answer is. You're going to need to go on to Performance Matters and answer the question for yourself. So you may want to pause, play this video, and have Performance Matters open in a separate tab so you can go back and forth between the tabs of this video and of Performance Matters. Okay, so for question number 1, it's asking you to compare using less than, greater than, or equal. And we have the two numbers, the square root of 36. We're comparing it, that's what's going in that box there, the comparison symbol, to an 18. So the square root of 36, that is actually a perfect square. So I hope that you have it memorized, because what number times itself is 36? 6. But remember that you can use a calculator. If you have a calculator like this one here, you would want to hit the second key. And then if you look down here, you can see that square root symbol. It's called a radical sign right above the x to the second button. So when I select that, it makes the radical sign on my calculator. And then I'm going to put in 36. I don't need to close the parentheses. You can, but you don't have to. And then I'm going to hit enter. And it tells me that my answer is 6. So again, square root of 36 is 6. I am comparing that to 18. So again, I am not going to tell you what the answer is, but you are going to be choosing greater than or less than, greater than, or equal to. Okay? All right, moving down to question number 2. It says determine if each number is rational or irrational below. So what we're going to be doing is we're going to be making a check mark in either the rational or the irrational box. Now, these are all in very different size fonts for some reason. It might look a little bit different on the computer, but when I printed it out, this is how it looked. So I'm going to talk to you about each type of number, and I'm going to say like the qualities of that number. But again, I am not going to tell you whether it's rational or irrational. You will have to make that choice. So this first number here is 0.51515151 ... This is a repeating decimal. So then now you need to decide, is a repeating decimal rational or irrational? The second number is pi. So what we know about pi is, even though most of us have 3.14 memorized, this number does continue on forever and it does not repeat. So it doesn't terminate. Doesn't terminate, that means stop, or repeat. So because it is a decimal that doesn't terminate or repeat, is it rational or is it irrational? You decide. The fourth number is a -5/8. This is a fraction, and in this fraction, you have a whole number on top and a whole number on bottom. So it's just a normal looking fraction. It doesn't matter that it is negative. So is a fraction rational or irrational? We could even change this fraction into a decimal number to see what type of decimal number it is. So remember, to change a fraction into a decimal, you do top divided by bottom. So if I did 5 divided by 8, it's 0.625. So this would be a -0.625, which is a terminating decimal. So again, terminating decimals, is that rational or irrational? All right, moving on to the next number, which is the square root of 81. Now, you may not have your perfect squares memorized, so we can check to see if this is a perfect square by using our calculator. So I'm going to do the square root of 81, and it is 9. So because this is a perfect square, is this rational or irrational? And then there is one more, the square root of 5. Again, check to see, is this a perfect square or not? Let me get the glare off my calculator. There we go. All right. So the square root of 5. And you can see it's a decimal number that fills up my entire screen. So it's about 2.2. But again, that decimal doesn't terminate or repeat. So this is not a perfect square. So if it is not a perfect square and it makes a decimal that doesn't terminate or repeat, does that make it rational or irrational? Okay, moving on to question number 3. So for question number 3, it says, order the set of numbers from least to greatest, with least being on top and greatest at the bottom. So when you're doing this on Performance Matters, you will be able to like click on the tiles and drag the tiles up and down to change the order. Obviously on this piece of paper, I cannot move the tiles around. So what I'm going to do is I'm going to rank them with 1 being the smallest and how many? 1, 2, 3, 4, 5 being the greatest. Okay. But again, on the actual computer, you would drag them around. So let's talk about just what these numbers equal first. So for pi, you need to use 3.14. Here we have this 3.25. Here we have a negative 2.75. Here we have a negative. To change a fraction into decimal form, we're going to do 9 divided by 2. So when I use my calculator and I do 9 divided by 2, I get 4.5. So this is a negative 4.5. And then this means absolute value. Absolute value. We've talked about absolute value. Absolute value is the distance from 0 on a number line. So negative 3 is how many places away from 0? It is 3 places away. Absolute value is always going to be a positive number. Okay, when you're ordering these from least to greatest, I would hope everyone knows that the negative numbers are going to be the smallest numbers. Be very careful when you're ordering your negative numbers. You have to kind of think backwards when you're ordering your negative numbers. So think about, these are going to be 1 and 2, okay, the 2 smallest ones, but think about which one of these is actually the smallest number. Be careful. And then you will order your 3 positive numbers, okay? Just take your time. If it helps you, you can kind of think about money, okay? $3, $3.14, $3.25. So again, you order them on your own. For question number 4, it says, drag and plot the following numbers to the approximate place on their corresponding number line. We have a number line for the rational numbers and we have a number line for the irrational numbers. So it's kind of like practicing 2 skills at the same time. First skill is, can you put it on a number line? Second skill is the number rational or irrational? On the computer, you actually have little spots that you can see where you can drag them. So you would take the number and again, you would drag it to the spot on the number line. On this piece of paper, I'll have to do things a little bit differently though. So this negative 3.75 is a terminating decimal, okay, a terminating decimal. I'm going to help you out. That's going to go on the rational line. A negative 8 is an integer. That's going to go on the rational line. Pi, for pi, we're going to use 3.14. That'll help us put it on the line. And this is going to go on the irrational line down here. The square root of 49 equals 7. And since it's a perfect square, that would go on the rational line. Negative 4 over 2 means negative 4 divided by 2, which is negative 2. That would go on the rational line. Pi plus 2. So because pi is in this expression, it's going to be irrational. This would be like saying 3.14 plus 2, which would be 5.14. And again, this is going to be irrational because the pi is in the expression. 2 over 5, we would do 2 divided by 5 in a calculator, which is 0.4. It is a fraction. This is a terminating decimal that makes this rational. And then the square root of 50 is not a perfect square. So I'm definitely going to want to use my calculator for that. Square root of 50 is 7.0. 7, okay? And it goes on from there, but because it is not a perfect square, it is irrational. So again, pi plus 2 and the square root of 50, those are the three numbers that are going to go down here on this line. And then negative 3.75, negative r, square root of 49, negative 4 over 2, and 2/5 are going to go on this line. Okay, so pay attention to where you are putting them. Again, on Performance Matters, it has a spot for you to drag it to. All right, then the last question is question number 5. It says, Larry thinks that the square root of 5 over 9 is a rational number because it can be written as a fraction. Mindy thinks that square root of 5 over 9 is irrational because the square root of 5 is irrational. Who do you agree with and why? Justify your answer using mathematical reasoning. So this question is a little tricky, I agree, because we have talked about when we are saying what numbers are rational, what numbers are irrational. I admit I am the one that has said if it looks like a fraction, it's rational. However, when you have a fraction that has a number in it that is irrational, then it does actually make the whole thing irrational. So who do you agree with and why? Okay, so we need two things here. Who do you agree with? Your choices are Larry and Mindy. So you have to pick. I agree with blank, Larry or Mindy. Those are your choices. And then you're going to say why. The reason they are correct is because, and then you're going to say your reason. Okay. So again, I'm not telling you exactly what to type here, but if you have a number that is written in fraction form, if you have some numbers in that fraction that are irrational, like if I put pi over 10, even though this is in fraction form, because one of the numbers is irrational, it makes the whole thing irrational. Okay, so the numerator has an irrational number. Which makes the fraction irrational. So again, this is just an example. It's different than the example up here, but the absolute or the square root of 5 is not a perfect square. So if it's not a perfect square, that means that square root of 5 is irrational, which would then mean what? Okay. Again, hopefully that helps you. I kind of have this, what you need to say here. I agree with blank, Larry or Mindy. And the reason they are correct is because, and tell me why in your own words. Please also make sure when you're done with the DMA, that is 5 questions, it's only one section, that you do hit submit.